Okay, folks, in this video, I'm going to show you how you can use the central limit theorem to compute various probabilities related to sample mean. For example, in this case, you want to compute the probability that the sample mean is going to be less than or equal to 26.02. Now, when you're computing these probabilities, some of the information will be given to you already. For example, where the sample came from, what is the sample size, and so on. So the given information is this sample has come from a population with mean 30 and the variance 221, and the sample size was 38. So this information is given to you. You're going to use this information to convert this x bar into an equivalent event. Converting this event of x bar is less than 26.02 into an equivalent event in terms of z. How you're going to do that? You're going to use this formula right here. And because of the central limit theorem, x bar follows a normal distribution with mean mu and the standard deviation sigma over square root of n. And that is the reason this ratio here follows a z distribution. So how can you compute this z value? You're going to say equal to x bar, in this case 26.02 minus the mean is 30 divided by SQRT of 221 divided by 38. Remember, you have to take the square root of sigma square also because the formula asks you for sigma, not sigma square. Sometimes a student makes a mistake right there. So you have to take the standard deviation, not the variance. This is variance. Okay, divided by square root. Okay, so enter, you got negative 1.65. So you want to compute the probability that z is negative 1.65. That's what you want. Now, if you look at the z distribution right here, and negative 1.65, z distribution is right here. I'm going to just center it a little. 1.65 is right here, 1.65. So you are looking at this blue area. And you can compute that. The left-sided probability you can compute by using norms dist formula equal to NORMS DIST of this number, 1.65. Parenthesis closed. You can type that number also. So this 0.049435. So this area is 0.049435. You remember this whole area is 1. So in other words, this area is 4.94%. Now again, never express probability in terms of percent. Probability should be always in decimal or in fraction. Chance is in percent. Okay, so this is left-sided probability. Another type of question would be the right-sided probability. For example, in this case, you want to compute the probability that x bar is greater than 32.77, okay? 32.77, okay. So equivalent probability in terms of z, these are the information given to you, same as before. So z is equal to 32.77 minus 30, which is the mean, divided by SQRT of 221 divided by 38. Have I done it correctly? Yes, I think so. Okay, good. Enter. So it's approximately 1.15, we are going to say. So the equivalent event is what? 1.15. Okay, so you want to find out this probability, 1.15. Now looking at the normal distribution curve, you'll see z distribution curve rather, it is this. It is this. And 1.15 is right here. 1.15 is right here. So now greater than 1.15, you are looking at this colored area on the right hand side. Now, if you use Excel formula, you have to, for the right-sided probability or the right-sided area, you have to use 1 minus NORMS dist of this number, right parenthesis, so 0.125357. So this area is 0.125357. In other words, this area is the 12% of this entire area. This is the probability. So you computed the probability that x bar is greater than 32.77 is this if these samples are collected from the population of mean 30 and the variance 221 and the sample size was 38. Now there is another type of question you will be asked which is two-sided. For example, x bar is less than this and greater than that. So there is an upper limit and there is a lower limit. So you have to convert now into z into two equivalent z's, one for the upper limit, another for the lower limit. So for the upper limit, you're going to do exactly the same thing. You're going to say equal to upper limit is 33.98 minus 30 divided by SQRT 221 divided by 38, right? So if you enter 1.65, okay, good. The lower limit is 2624 right here, 2624. So 26.24 minus 30 divided by SQRT 221 divided by 38. So 1.56, approximately 1.56. So you want to compute the equivalent probability of what? Equivalent probability of this, negative 1.56, and then here you want to compute upper limit is 1.65. So you want to say 1.65. You want to compute this probability. Okay, so if you look at the normal distribution, it is going to look like this. You're looking for these two numbers, these two numbers right here. So you want to find out the probability that z is between these two numbers, this green area. And you can use, again, Norm's dist formula. You can say equal to NORMSDIST, the higher value right here, minus NORMSDIST, the lower value right here. So, in other words, this whole area minus this white area will give you this green area. So enter, there is 0.891083. So this area is approximately 89%. Therefore, the probability that z is between 1.65 and 1.56 is 0.89, which is same as the probability that x bar will be between 33.98 and 26.24. Okay? All right. Thank you.